Good morning, dear students. Today we are going to solve May-June 2019 1-2 paper. It's a MCQ paper, and the course we are studying is Physics 5054 O-Levels, Cambridge Assessment International Education, O-Levels. Let's start this paper. Okay. The question on your screen is, which reading is given to 1/10 of a millimeter? 1/10 of a millimeter, this is the question, but the options given are in centimeter. So 1/10 of a millimeter means in centimeter, there are 1 centimeter is equals to 10 millimeters. So 1/10 of a millimeter will be 100th of a centimeter. 1 millimeter is 10th of a centimeter. 10th means 1 decimal place after in the centimeter. 1 decimal place after the point in the centimeter will be 1 millimeter. But 100th of a millimeter will be 2 decimal places in a centimeter. So which in the given options, which reading in centimeter goes to the 2 decimal places? This B. So this is correct to 10th of a millimeter because it is going after decimal, it is going to 2 decimal places, and the unit is centimeter. So B is the option. On your screen, we have question number 2. A woman runs 2 kilometers from X to Y, 2 kilometer in 20 minutes. So she takes 20 minutes here. She then rests at Y. She rests here for 10 minutes. She then takes 10 minutes to run 1.6 kilometer from Y to Z. From Y to Z, she covers 1.6 kilometer in 10 minutes. So 20 minutes here, 10 minutes rest here, and 10 minutes to cover this distance. 20 plus 10, 30 minutes, 30 plus 10, 40 minutes. So she has taken 40 minutes to move from X to Y and from Y to Z. The total time taken is 40 minutes. What is the size of her average velocity for the journey from X to Z? So the question is, what is the average velocity? Remember, his question is not average speed. His question is average velocity. Average velocity is displacement divided by time. The displacement is the minimum distance between the starting point and the finish point. The minimum distance between the starting point, which is X, and the finish point, which is Z, is 2.4 kilometer. So displacement is 2.4 kilometer. Divide the 2.4 kilometer with 40 minutes, and you will get the answer. So when you will divide 2.4 kilometer with 40 minutes, the answer will be 0.06 kilometer per minute. So A is the choice. I hope you have understood. Question number 2, A is the choice, 0.060 kilometer per minute. Question number 3 is on your screen. A cyclist traveling in a straight line at 8 meters per second accelerates to 12 meters per second in a time of 6 seconds. Which expression gives the cyclist acceleration? The formula for the acceleration is V minus U whole divided by T. Change in velocity divided by time. V minus U divided by T. Final velocity is 12 minus initial velocity, that's 8, divided by time, that's 6. So it will be 12 minus 8 divided by 6. So the D is the choice. You see here, the D is the correct option. So for question number 3, D is the option. Okay. On your screen, we have question number 4. The diagram shows the distance time graph for a moving object. What is the moving object? So you see here we have a distance time graph. The graph here, the gradient is constant, it means the speed is constant. Then the gradient starts decreasing, it means the speed started decreasing. And then the gradient becomes flat. Or the gradient becomes 0, the graph becomes flat. When the graph becomes flat, it means the speed becomes 0. So here we have an object which was moving with the constant speed, then the speed started decreasing, and then the speed becomes 0. So we have to decide that what is that object, what is that moving object. The A part is a ball thrown vertically upwards and falling back to the thrower. This is not the graph of an object which goes up and then comes down. A car starting from rest speeds up as it moves away from a traffic signal. If the speeds up, the graph of an object which speeds up, its distance graph will be a increasing curve. So B is not the option. A rock dropped from a high cliff falling into the sea below. So a rock which falls from a high cliff, its speed never decreases. Its speeds increases, and all of a sudden it becomes 0. So C cannot be the choice. D is a train braking to a halt as it stops at a station. That can be the choice, because the train which apply brakes, it's moving with a little bit constant speed, and then speed starts decreasing, and then the speed becomes 0. So this is the D is the option. It's little tricky. I hope you have understood it. So D is the option. Okay, on your screen we have question number 5. 4 of the gravitational forces that act between bodies in solar system are listed below. P, the force on the moon due to the earth. Q, the force on the earth due to the sun. R, the force on the earth due to the moon. S, the force on the moon due to the sun. Which two forces are a Newton's third law pair, action and reaction? So action and reaction are between two same bodies. For example, if the moon apply force on the earth applies the force on the moon. So that will be the Newton's third law pair. Moon apply force on earth and earth apply force on the moon. Both forces are equal in magnitude but opposite in direction. So P and R is a pair, Newton's third law pair, action and reaction. Opposite forces equal in magnitude, acting on different bodies. But in both the statements, the bodies should be same. So P and R is a pair, third law pair, Newton's third law pair. So B is the option. For question number 5, B is the option. Question number 6 is on your screen. A parachutist of mass 60 kg falls at a steady speed of 10 meters per second. The gravitational field strength G is 10 Newton per kg. What is the upward force acting on the parachutist? So he's falling with the constant speed. So when you are falling with the constant speed, the resultant force on you is 0, which means that the downward and upward force are equal to each other. That's why the resultant force is 0. The downward force is weight, and the upward force will be the air resistance, and that air resistance will be equals to the weight. The weight is W equals to mg. Mass is 60 kg, the G value is 10, so 60 multiplied 10, it will be 600 Newton. The upward air resistance should be equals to the weight. So the upward force must be 600 Newton. So D is the option. 600 Newton. D is the option. The upward force, which is air resistance, should be equals to the weight. So D is the option for question number 6. On your screen, we have question number 7. A force moves a box up a rough slope. So this box is basically moving upward on this ramp. The diagram shows 4 forces acting on the box, which is the force due to friction on the box. So when the box is moving upward, so this A force is the applied force, this C is the frictional force, this D is the normal reaction of the surface, this B is the weight of the box. So his question is, which is the force due to friction on the box? So C is the friction on the box, because friction is always opposite to the motion, and the box was going up on the ramp. So that's why the friction will be towards the on the ramp in the backward direction. So C is the frictional force. I hope you understand. C is the option for question number 7. On your screen, we have question number 8. The mass of object P is greater than the mass of object Q. So mass of the P is more than the mass of Q. The object contains different amount of matter and have a different resistance to change of motion. Which row is correct? You know, the mass, you define the mass as the amount of matter in a substance. So the object P has greater mass. So it will has greater amount of matter in it as compared to the object Q. We also use another term, inertia. Inertia is the resistance of an object to any change in state of motion. And the inertia depends upon the mass. So an object which has greater mass will have greater inertia, and an object with less mass will have less inertia. Greater inertia means greater resistance to any change in the motion. So the P has greater mass, so it will have the greater amount of matter in it, and it will have greater inertia, means it will have greater resistance to change of motion. So the greater amount of matter is also in P, and the greater resistance to change of motion is also in P. So A is the option for question number 8. Question number 8, A is the option. I hope you have understood it. Question number 9 is on your screen. 4 objects of different masses are situated in places with different gravitational field strengths. Which object has the greatest weight? So here the mass is given and the gravitational field strength, which you call G, small g, that is given. You have to calculate weight of every object, and then you have to decide that which one has the greatest weight. So take your calculator, take a notebook, and calculate the weight for every object. For example, for object A, you can calculate the weight by the formula mg, 3 multiplied 10.4. Here the g value is 10.4. 3 multiplied 10.4, and the answer will be 31.2 Newton. For object B, mg, weight equals to mg, 3.5 multiply 9.5, and the answer will be 33.25 Newton. For object C, the weight will be mg equals to 4 into 10.2, and the weight will be 40.8 Newton. For object D, the weight will be, the formula is mg, and 4.5 into 9, and the answer will be 40.5. So once you have calculated the weight for all the objects, the largest answer or the greatest weight is 40.8, which was object C. So object C has the greatest weight. So for question number 9, C is the option. Kindly do this calculation on a paper, use your calculator, and it's very simple. So C is the option for question number 9. I hope you have understood it. Okay, on your screen we have question number 10. A uniform meter rule is balanced by a 4 Newton weight as shown. What is the weight W of the meter rule? Here on this diagram you can see that we have a meter rule. It's balanced on this pivot. On this left end we have hung a weight of 4 Newton, and on this 50 centi mark we have the center of gravity of the ruler. Here its weight is acting. The pivot is at the mark of 10 centimeter. This weight 4 Newton is trying to produce counterclockwise moment, or you call it anti-clockwise moment. This weight of the ruler is trying to produce a clockwise moment about the pivot. Because this whole assembly is in balance, it means that the clockwise moment and the anti-clockwise moment, they both are equal to each other. So you can say that F1 multiplied D1 is equals to F2 multiplied D2. F1 is 4 Newton and the D1 is 10 centimeter. So 4 Newton multiplied 10 centimeter equals to weight. We don't know that. We want to calculate this. Multiply the distance between the pivot and the center of gravity here is 40 centimeter. So you do the calculation F1 D1 equals to F2 multiplied D2. 4 multiplied 10 equals to W multiplied 40. So if you make the W alone, W equals to 40 divided by 40. And the answer will be 1 Newton. So weight of the ruler is 1 Newton. I hope you have understood it. Please do this in a copy. If you will write these are numerical, you write it and you actually calculate it, you will understand it. Okay, don't only depend upon listening and watching. Actually write it and do the calculation. Okay. So for question number 10, A was the option. So now we are moving to next question, which is question number 11 on your screen. A large hook sticks into a pencil. The hook and pencil are balanced on the edge of a table as shown. Where is the center of the mass of the hook and pencil? Remember that thing. The center of the mass can be inside the body, it can be outside the body. And you might have seen this kind of toys. You might have seen eagle, which is balanced by its beak, supported by its beak, and it can move up and down and it do not fall. You disturb it, it do not fall. So it is in the stable equilibrium. The reason is that the center of the mass of the object is under the point of support. So here the center of the mass should be B, which is right under the support point. This is the support point, this is the center of mass. So B is the option. Question number 12, the diagram shows a graph of load against extension for a material. At which point is the limit of proportionality? It's a load and extension graph. The limit of proportionality is that point till which the graph is a straight line. So A is the limit of proportionality. For question number 12, A is the limit of proportionality. So A was the answer. Question number 13 is on your screen. The length of a metal wire is made from a radioactive isotope of metal. The diagram shows masses suspended from the end of the wire. The masses are removed from the wire. Which property changes? So when you will remove this load, you know, when you hung these loads, the length, there will be a little bit extension in the wire. The length would have become longer. When you will remove them, and we believe if the limit of proportionality is not crossed, when you will remove them, the length will decrease. So the masses are removed from the wire. Which property changes? Half-life of the isotope, that cannot be changed. Length of the wire, yes, this is the answer. Mass of the wire, the mass of the wire cannot be changed by this method. Melting point of the metal, that do not change. So length of the wire will change when you will remove the masses, it will become shorter. So B is the choice. For question number 13, B is the choice. Here. Question 14. The diagram shows a manometer containing mercury that is sealed at one end. What happens to the distance h when the manometer is taken higher up a mountain? So this is this level, the difference of this level, tell you the difference of the atmospheric pressure and the vacuum. So when you take it to the top of a mountain or higher up a mountain, when you go up to the top of the mountain, the atmospheric pressure starts decreasing. So when the atmospheric pressure will start decreasing, this difference in the level of mercury in both the limbs will also start decreasing. So A choice is what happens to the distance h when the manometer is taken higher up a mountain. A choice, it decreases because atmospheric pressure decreases with the height. That is the answer. So question number 14, A is the answer. We don't need to read the next. But when you are actually attempting a paper, you should always read all the 4 options. A is the choice. Okay, sir. Question 15 is on your screen. The pressure on the gas contained in a sealed syringe is slowly doubled. Sealed syringe means that you cannot change the volume. Oh, sorry. The pressure on the gas contained in a sealed syringe is slowly doubled. The volume of the gas halves. What must be true about the density and the temperature of the gas? Sorry, sealed syringe means that it's one end is sealed. I said the volume cannot be changed. He said the pressure has become doubled. The volume of the gas has become half. What must be true about the density and the temperature of the gas? You know, in our course, when we study about the pressure of gas, if you are changing the pressure and the volume, the temperature is kept constant. And so the temperature should remain same, constant. Because the volume of the gas has become half. So when the density, you know, is mass divided by volume. So if the volume will become half, the density will become double. So density should increase and the temperature should remain constant. So question number question number 15, C is the answer. Density increases because the volume has reduced and the mass of the gas is still the same. And the temperature, you know, we are changing volume and the pressure, so we assume that the temperature do not change. In our course, the 3 things do not change together: volume, pressure, and the temperature. We only study, when we study the gas laws, we only change 2 things. The 3rd thing is always kept constant in our course. So C is the option, sir. Okay, on your screen we have question number 16. An object is lifted. Which expression gives the increase in the gravitational potential energy of the object? You know, the gravitational potential energy is mgh, or it could be weight multiply height. So D is the option, weight multiplied by the increase in the height. So D is the option. Question 16, D is the option. Okay. Question number 17 is on your diagram, on your screen, sorry. The diagram shows a small car of mass 500 kg approaching a hill. It moves up the hill with constant speed. The gravitational field strength G is 10 Newton per kg. Ignoring friction, how much work is done by moving the car up the hill? So when you move the car up the hill by this ramp, calculating how much work is done, there are two methods. One method is, if you know the driving force and you know the distance traveled in the direction of the driving force, you multiply them, F into D, you get the work done. But if you don't know the driving force, another method of calculating the work done when something moved on a ramp is by calculating the gain in the potential energy. And the formula for that is mgh. Mass multiply g value, gravitational field strength, multiply height, the vertical height you gained. In this case, the vertical height gain will be 10 meter. The mass of the car is 500 kg, and the g value is 10 Newton per kg. So apply the formula. Work done is equals to gain in the potential energy, gravitational potential energy, mgh. So 500 multiply 10 multiply 10, and the answer will be 5 expo 4 joules. 5 expo 4 joules. So it looks B is the option. It looks B is the option. You see, whenever we do a numerical, this is a numerical question, story sum, please do it on a paper. Actually do the calculation. Use your calculator. For example, I'm saying 5 expo 4 joules. So you should know how to use your calculator and actually do this numerical in your copy. Then you will actually understand. But just watching and listening, it's not enough. So please do this calculation on a copy also. So B is the choice for question 17. Okay, on your screen we have question number 18. Which method of producing electricity does not use an AC generator? Geothermal power station, it involves a generator. Solar panels, it do not involve a generator. Wave energy generators, it involves generators. Wind turbine also involves generators. So solar panels do not produce do not use alternating generators. So B is the option. Question 18, B is the option. Okay, on your screen we have question number 19. 3 solar panels have a total area of 7.2 meters square. So the total area of the 3 panels, combined area of the 3 panels, solar panels, is 7.2 meters square. Together they produce 1 kilowatt of power. So the output power is given 1 kilowatt. Output power is given 1 kilowatt. An area of 1 meter square of each panel receives 0.80 kilojoules of energy from the sun in 1 second. What is the efficiency of the solar panel? So this is the input energy given to us. So 1 meter square area gets 0.80 kilojoule of energy from sun in 1 second. So I can calculate from here the input power also. The input power will be, 1 meter square area is getting 0.80 kilojoules. So 7.2 meter square area will get how much energy? You multiply 0.80 kilojoule with 7.2 to convert it to power divided with time. So 0.80 kilojoules multiply 7.2 meter square divided by 1 second. The answer will be 5.76 kilowatt. This will be the input power. So the input power I just calculated is 5.76 kilowatt. And output power is already given in the question statement. It is 1 kilowatt. The formula for the efficiency is output power divided by input power multiply 100. So it will be 1 kilowatt divided by 5.76 kilowatt multiply 100, and the answer will be 17%. So B is the choice. Question number 19, B is the choice, 17%. You see, it's a numerical. And I have given you instructions that how this calculation is done. I have already done this calculation on a paper. So please do this calculation on a paper yourself. Use a calculator. Do it yourself. Then you will be able to understand this numerical. Okay, question number 20 is on your screen. A student suggests 3 different definitions for power. First is energy transferred per second. Second is force multiplied distance moved. Third is rate of doing work. The power, definition of power, the first one, energy transferred per second, this is right definition. Second, force multiplied distance moved, that's wrong. This is the definition of the work. The second one is wrong. Third one is rate of doing work, that is true. This is the definition of power. So first definition and third definition, they both are correct. Which definitions are correct? One and third only. So C is the option. Question number 20, C is the option. Question number 21 is on your screen. Which statement is correct? Infrared radiation cannot travel in a vacuum. That's wrong. Infrared radiation cannot travel in solids or in gases. It can travel in gases. Infrared radiation can only travel in a vacuum. The word only is wrong. Infrared radiation can travel in a vacuum and in gases. This is perfectly correct statement. So for question number 21, D is the option. Question number 22 is on your screen. How is latent heat defined? Latent heat is the heat absorbed or given out when the state change is taking place in a body without any change in the temperature. The thermal energy absorbed or emitted during a change of state without a temperature change. So C is the option, but remember one thing, do not confuse it with the specific latent heats. In this question, he is talking about the latent heat only, not the specific latent heat. So that's why we have not chosen that definition in which the unit mass is involved. It's only the latent heat, the thermal energy absorbed or emitted during a change of state without a change in temperature. So for question number 22, C is the option. The next question on your screen is question number 23. In low pressure hydrogen, there are no forces between the molecules except during collision with each other. So in low pressure hydrogen, there are no forces between the molecules except during collisions with each other. Which statement describes the motion of a molecule between one collision and the next? So when the molecules collide, let's say the molecules collide, then this molecule will move in the, suppose it collide here and moves in this direction. So it will be moving with a constant speed, okay, and in a straight line, because there are no other forces. So after the collision, the molecules will be moving in a straight line with a constant speed because there are no other forces. So it moves with constant speed in a straight line. Question number 23, D is the option. Question number 24 is on your screen. A gas is enclosed in a container of fixed volume. The gas gains heat energy from an external source. The volume is not changing. He said fixed volume. The gas gains heat energy from an external source, so its temperature will rise. The rise in the temperature means that the molecule of the gas, they will move faster. So what happens to the molecules of the gas A? They expand? No, the molecules don't expand. Never. They never expand. Don't never say molecules expand. They move faster inside the container. Yes, their temperature rises, their average kinetic energy rises, which means they are moving faster. So B is the option. They move further apart. That's not possible because the volume is fixed. They vibrate with greater frequency. They are moving. This is gas. They are moving around. They're not just vibrating. So the best answer, the best statement is B. They move faster inside the container. For question number 24, B is the option. Question 25. A wave on water travels towards a stationary boat. As the wave passes, the boat starts to move up and down and gains kinetic energy from the wave. The property of the wave changes as the wave passes the boat. So when the waves reach here, they move this boat up and down. So they have given some of their energy to the boat. So the wave has lost some of its energy. So when the wave will pass beyond this boat, the frequency of that wave will not change. The wavelength of that wave will not change. The speed of that wave will not change. The one thing, because it has lost some energy, now the amplitude of this wave will be a little smaller as compared to the wave before the boat. So the amplitude of the wave will change. For question 25, A is the option. Okay. Question 26 is on the screen. Which waves are longitudinal? Which waves are longitudinal? Gamma rays. Gamma rays are electromagnetic. They are transverse waves. Light waves. They are transverse waves. Ultrasound waves. They are sound waves. They are longitudinal. This is the option. X-rays. They are longitudinal. They are transverse waves. They are part of the electromagnetic spectrum. They are transverse. Only the ultrasound is not the part of electromagnetic spectrum. They are transverse. They are longitudinal waves. Ultrasound waves are longitudinal waves, the waves which have compressions and rarefactions. So C is the option. Question number 26, C is the option. Question number 27. An object is placed at a distance from a converging lens that is equal to twice the focal length of the lens. Which statement about the image is correct? You know, 2 focal length means 2f. If you remember that table which is in your textbook, we find the location of the image by placing the object at different locations in front of a converging lens. When you put an object on 2f, the image is also formed on 2f. The size of the image and object is same. The image formed is real. The image form is inverted. Which statement about the image is correct? It is enlarged. That's wrong. It is inverted. Yes, it's true. It is on the same side of the lens as the object. No. It is virtual. No, it's real. So B is the right option he has given. It is inverted. Question 28. The lens in the diagram produces an image I of the object O. Why is this not the ray diagram for a photographic enlarger? You know, when we use a photographic enlarger, that makes a real image on a screen of a photograph. This diagram is making a virtual image. It's a magnifying glass. It is making a magnified image, but it's a virtual image. In a photo enlarger, the image is magnified, but it is real. It can be captured on a screen. So why is this not the ray diagram for a photographic enlarger? The image is magnified. The image is virtual. Yes, this is the reason. It's virtual. We want a real image. The lens is a converging lens. In both cases, we use converging lens. The lens is too thin. That's a nonsense. So the reason why this is not a photographic enlarger, because the image formed is virtual. In the photographic enlarger, the image formed should be a real image which can be captured on a screen. For 28, B is the option. Question 29 is on your screen. What is the approximate range of audible frequencies for a healthy human ear? It is from 20 hertz to 20,000 hertz. 20 hertz to 20k kilohertz. So C is the choice. For 29, C is the choice. Question number 30 is on your screen. The speed of the sound in air is Ca. The speed of the sound in water is Cw. And the speed of the sound in ice is Ci. Which relationship is correct? You know, the speed of the sound in solids is largest, greatest. Speed of the, then the speed of the sound in the liquid, and the speed of the sound in the liquid is more than the speed of sound in the air. The speed moves fastest in the solid, slower in liquid, and the sound travels slowest in the air. In solid, it will be fastest. In liquid, it will be slow. And in the gas, it will be slowest. So what is the right option given here? Speed in air will be more than speed in the ice? No. Speed in the air will be more than the speed in the water? No, that's wrong. Speed in the ice will be more than the speed in the water. Yes, the speed in the solid, the speed of sound in the solid will be more than the speed of sound in the liquid. So C is the right option, sir. C is the right option. Question number 30, C is the option. Okay. One end of each of the two bars is marked with an X or a Y as shown. So bar 1 and bar 2, there are two different materials and their ends are marked. One here, bar 1, its one end is marked as X. Bar 2, its one end is marked as Y. And X of bar 1 is brought close to North Pole and then to the South Pole of a magnet. And Y of bar 2 is brought close to the N pole and then to the South Pole of the magnet. The table shows what happens. So, end X of bar 1, when brought near to the North Pole, it was attracted. And when it was brought near to the South Pole of the magnet, it was again attracted. So this X end is attracted by the North Pole and it is also attracted by the South Pole. This shows that the bar X is a magnetic material. Okay, look at bar 2, its end Y. When it was brought near the North Pole, it was attracted. But when it was brought near the South Pole, it was repelled. This means the repulsion shows that the bar 2 is a magnetic, it's a magnet itself. It's a magnetized material. Because magnetized material will, its end Y will be attracted by one pole and it will be repelled by the other pole. So Y bar 2 is a magnetized, something magnetized. So he says, what materials are bar 1 and bar 2? Bar 1 is a magnetic material which is attracted to both north and south. Its end X is attracted both to North Pole and South Pole. So that shows bar 1 is a magnetic material. So it could be iron. Bar 2, its end Y was attracted to North Pole, but it was repelled by the South Pole of another magnet. So this means that the bar 2 is a magnetized, something magnetized. Something magnetized could be steel, because steel makes permanent magnets. It can retain magnetic properties for a longer time. So bar 2 is steel, and the bar 1 is an iron. So B looks the option. This was question number 31. For 31, B is the option, sir. Okay, on your screen we have the diagram shows a car ignition switch and a starter motor. And you know, here they have shown a relay, and here we have the ignition switch, here we have a relay, and here we have a starter motor. Here relay has relay can operate this switch, these contacts. Why we use relay? Remember, relay works on a very small amount of current, on a very small amount of voltage. But this starter motor works on a large current and large voltage. So we do not want to touch that large voltage or large current. So we operate this starter motor with relay. We touch the switch of the relay only, which has small current, small voltage. Let's look at the options. The ignition switch is in a circuit with long, thin wires. The starter motor is in a circuit with short and thick wires, because the starter motor has large amount of current, 100 ampere, 100 ampere, very large amount of current. So its wires must be thick wires. Their diameter should be larger. But the relay has only 1 ampere current, so it can have thin wires, because thick wires have low resistance, because there are 100 ampere current in it. So we need to use the wires which have low resistance, otherwise there will be too much heat produced. What is the explanation for the choice of wires? Each circuit needs to contain the small total mass of wire. No, the thicker wires heat up more quickly when relay is switched on. No, the thin wires have low resistance. That is the thin wires have high resistance. Remember, thin wires have high resistance. So C cannot be the answer. The ignition switch circuit carries a small current than the starter motor circuit. That is the answer. Because the ignition switch circuit has only 1 ampere current, so its wire can be thin. But the starter motor has very large amount of current. Its wires need to be thick. So for this question, this was question number 32. D is the option, sir. Little bit tricky question for you. Especially this diagram. This diagram was not in your textbook, na? Physics matters. Okay, on your screen we have question number 33. Let me increase the size a little bit. Yeah. Further. The diagram shows a simple circuit. What happens when the resistance of the variable resistor is increased? When you will increase the resistance of this variable resistor, so this will start taking more voltage. The whole resistance of the whole circuit will increase. The current coming from the battery will decrease. It will start taking larger voltage. Whatever voltage was taking before, now it will take larger voltage. The voltage drop here, here, and here, that will be less. The amount of current flowing through all of them will be less. So the power here, the power here, and the power here will be less. So the lamps will become dimmer and the motor will become slower. What happens when the resistance of the variable resistor is increased? The lamps are dimmer and the motor rotates more quickly. That's wrong. More quickly is wrong. The lamps are dimmer and the motor rotates more slowly. This is the answer, sir. B is the option. For question number 33, B is the option. Okay. Question 34. The diagram shows a simple electric circuit. Which statement cannot be correct? First statement is the current I is 2 ampere. 2 ampere, that's possible. The unit is correct. 2 ampere for current. Yeah, it could be possible. The EMF E is 12 joules. The unit of EMF is not joules. The unit of EMF is volt, or it is joules per coulomb. It cannot be only joules. So B cannot be the correct answer. C is the potential difference across the resistance 10 volt. That is possible. The resistance R is 5 ohm. That is also possible. Only the B is wrong statement. So it's question of which statement cannot be correct. So B cannot be correct. EMF cannot be 12 joules. The unit is wrong. B is the answer. Question number 35 is on your screen. The cable on an electric cooker contains a live wire, a neutral wire, and an earth wire. When the cooker is working correctly, in which wires are the currents equal? The current coming from the main supply by the live, and the current going back to the main supply through the neutral, they are always equal to each other. So the current in the live and the neutral wire are equal. So D is the option, sir. Question number 35, D is the option. It's a conceptual question. Okay, on your screen we have next question. The manufacturer of an electrical heater states that only one heater must be connected to the mains wiring through any fuse. The current in the circuit the current in the circuit with only one heater is 9 ampere. The fuse rating is 10 ampere. Despite the warning, a second identical heater is added as shown. When the switch is closed, the fuse blows. Okay. The fuse is replaced with a 20 ampere fuse. What happens? The fuse is replaced with a 20 ampere fuse. What happens when the switch is closed? Each heater only receives half the current, correct current. You know, because when you connect the two heaters in parallel to each other, their total resistance will become half of, so the current will be increased. So they will be still getting the same amount of current as when there was a single heater. So A is wrong. Each heater receives twice the correct current. No, that's wrong. The circuit wiring connecting the heaters to the main may overheat. That's possible. The fuse melts when the heaters are switched on. The fuse now you connected is 20 ampere, so it will not blow. So the C looks the good answer. 36 C is the option. It was very, very tricky question. It's the first time this kind of question is in the paper. The circuit wiring connecting the heaters to the main may overheat. The fuse will not blow because now you have put a 20 ampere fuse. So the C is the right answer, sir. Okay. Let me reduce the size. Yeah. A coil in rotating in a magnetic field. The coil is connected to an oscilloscope. The diagram shows the trace on the screen of the oscilloscope. The coil now speeds up and rotates twice as fast. Now you see, on this actual display, we have how many waves? One wave, two waves. So in this display, we have two waves. And what is the amplitude of the wave? From mean position, it is going 2 squares up. So amplitude is 2. Or from the mean position, it is going 2 squares down. So the amplitude is 2. So when you will increase the speed of the rotation double, you make it double, the amplitude should become 4. Before it was 2 squares, now it should become 4. And the frequency should also become double. So now in the same display, you should have 4 complete waves. And the amplitude of those waves should be 4. Look at the given options. Look at them carefully. To me, B is the option. because on the same display 4 waves are shown and their amplitude has increased from 2 to 4. So B is the right option, sir. Question number 38 is on your screen. A teacher, is a very tricky question. A teacher uses the circuit shown. The identical lamps X and Y are connected to a low voltage AC power supply by a high resistance transmission wire. So these transmission wires, these wires which are bringing in the current and taking back the current, they are not the wires which you study in your course. Because when we study transmission wires in our course, we suppose that they don't have resistance. These transmission lines don't have resistance. We never thought that they have resistance in our course. But in this question, he's saying that these lines have very high resistance. This line which is bringing, or this line which is taking back the current, or they both wires have high resistance. Lamp X, both lamps are switched on. Lamp X is then switched off. Lamp Y stays switched on. What happens to the voltage and the power supply to the lamp Y? You know, these two are in parallel to each other. So here, consider this also as a resistance and this as a resistance. So this is resistance number 1. This is resistance number 4. This is a resistance and these two are connected in parallel to each other. So their combined resistance, because they are connected in parallel to each other, will be less. But when you remove this X, this resistance will become larger. Okay. So now the voltage drop here will be larger. But the current coming from the battery will become small. Current coming from the power supply will become smaller. So because the voltage drop across the Y will now increase, because before here they were parallel to each other, their combined resistance was smaller, and the voltage drop on each of them was equals to each other, and the voltage drop was depending on their combined resistance. When you removed X, the resistance of the Y will be more than the combined resistance of these two when they were parallel. So here this resistance will be now more, the total resistance will become larger. So now Y will take more voltage. So the voltage supply to lamp Y will increase. The power supply to lamp Y, when this will increase, the current will decrease. So the power supplied may be stay the same. For 38, or wait a minute. But now, you know, the current coming from the main supply will change also a little bit. But because the voltage has increased, we might say that the power has also increased. Because the current will decrease a little bit, but because the voltage has increased, so that will be, the power is voltage multiply current. Na? The current will little bit decrease. But due to the voltage increase, we can say the power will also increase. So C is the choice for question number 38. C is the choice of very, very, very tricky question. So think about this again. Okay. Question number 39 is on your screen. A car battery supplies a current in one direction. A current in the opposite direction recharges the battery. The circuit recharges the battery using an alternating current supply and a diode. Okay. Which circuit recharges the battery? Okay. To recharge a battery, you have to provide a current which enters it from the positive terminal of the battery. And because here you have provided an alternating power supply, so direction of the current is changing. Once it flows like this, then it flows like this. So when the current flows like this, it will not be recharging the battery. When the current flows like this, then it will be recharging the battery. Here you have connected a diode. This diode will only let the current flow in this direction. It will recharge the battery, but when the current will flow in this direction, the diode will be in the backward biased, and so it will not let the current. So the battery will, so current cannot flow in this direction. So only in this direction the current can flow, and it will be recharging the battery. So A is the answer. For question number 39, A is the question answer. A little bit difficult thing. Okay, on your screen we have question number 40. A proton has a charge Q and mass M. What is the charge and what is the mass on an alpha particle? The alpha particle has 2 protons and it has 2 neutrons. Protons have charge, but neutrons are neutral. So those 2 protons will have 2q charge. So the charge on the alpha particle will be 2q. The mass of the proton and the neutron is almost same. Because alpha has 2 neutrons and 2 protons, so total they are 4. So their mass will be 4m. So charge will be 2q and the mass will be 4m. So for question number 40, it looks C is the choice. So by this question, we have reached the end of this paper. Okay, dear students, today we have solved 2019 May-June paper 1-2. It's an MCQ paper. I have tried my best. It has a lot of tricky questions. I have tried my best to explain you the concepts. If you will keep working and learning, I believe that you will improve. Your answering skills will improve. And thank you very much, everybody. And have a good day. God bless you all. Thank you very much.